Ladies and gentlemen, welcome to adding and subtracting rational expressions. We'll start out with something simple. We've got 5/8 plus 5/6. We're adding fractions, taking you back a ways to your younger years. Now, I know that many of you are going to say, all right, well, what's the least common denominator there? Oh, it's going to be, we got 24. Okay. Well, I would really like to talk about this in terms of prime numbers. So I factored the denominators. 8 I factored into 2, 2, and 2. And 6 I factored into 2 times 3. Now, there's a reason why I did that. The reality is that to build a least common denominator, we need to factor the denominators and multiply by the missing factors. So in other words, I'm going to look at this right here, and I'm going to say, what is this denominator missing that this one has? And I can clearly see that it's missing a 3. So I'm going to multiply the top and bottom of that fraction by 3. What is this denominator missing that this one has? Well, it looks like this one has a couple extra 2's in it, and that's what I'm going to multiply this one by, the extra 2's. Now, I know you're not used to doing that. Usually you'd be multiplying by 3 and by 4. But when we start getting into polynomials, which we will be doing in this lesson, you need to be able to break it down into its factors and multiply and build a least common denominator. So, yes, this would be 15 over 24 plus 20 over 24, which would be 35 over 24. Right? We need to be able to do that. Now, example 1 shows me a situation which is a story problem. And they show you a really cool picture if you want to look at it in the book. It's talking about you've got an object, and I think they use a house, and a lens on a camera. And I'm really going to draw a bad picture, so I'm going to try to find this picture so I can look at it and draw it with you. Alright. And remember, every camera has like a lens on it. A lens. Okay. And then the film, I know it's digital now, so it's actually a sensor. Maybe I should write sensor in order to be up to date with the times. Whoops, and I covered up the picture. Well, and so your object is actually upside down on the sensor. So we can talk about the distance from here to here as being f, the focal length. The distance from the lens to the sensor is d sub I, and to the object, d sub O. So that's the picture that the book draws, which is really pretty cool. This is what happens in every single camera when it focuses on an object. So let's see here. We have a length distance to the object from lens to the film of 10, and a distance from the object to the lens of 15. Okay, so I substitute those values in. And I'm going to break this down into its prime factors. 10 is 2 times 5, and 15 is 3 times 5. Now I ask myself, what is this denominator missing that the other one has? Looks like it's missing a 3. So I'm going to multiply the top and bottom by 3. What's this one missing? This one's missing a 2. So I'll multiply the top and bottom by 2. So I have a denominator of 2 times 5, which is 10 times 3, or 30. And here I have 3 plus 2, which is 5, or 1/6. Now that's equal to 1 over f, little cross multiplication action would show me that f equals 6. Okay, so that's an example of a situation where we would be adding fractions. let's take a look at example 2, which is a least common multiple. And we want to find the least common multiple of these two expressions. Well, I need to factor this stuff. Right, I see 4 and x squared minus 9. Always look for a GCF. Always look for the greatest common factor. And then we can break this down farther. In fact, 4 gets broken down into 2 prime factors, 2 times 2. And x squared minus 9, which is a difference of perfect squares, is x plus 3 and x minus 3. So there's the prime factorization of 4x squared minus 36. Well, then we got this one, 6x squared plus 36x plus 54. Let's start with, of course, a GCF. 6 breaks down into 2 times 3, and this can be broken down into 2 sets of parentheses there. It happens to be a nice perfect square. So things that multiply together to give me 9 that add up to 6 are plus 3 and plus 3. Now, in order to actually find the least common multiple between these two things, we need to follow these steps. First of all, we need to factor. Yes, we've done that. Now we need to pick one and start adding factors from the other. So here's our least common multiple. We're going to pick one. So we're going to start with the first one, 2 times 2 times x plus 3 times x minus 3. Okay. So I just picked one of these. Doesn't really matter which one, but I picked one. And now I ask myself the question, what does this factor have that the other one's missing? Well, clearly it looks like it's missing a 3 and another x plus 3. So we've got 2 times 2 times 3, or 12, x plus 3, x minus 3, x plus 3. No, I'm not going to make you multiply all that out. Now, I did the 2, and the 3 because that's easy stuff. I'm not going to FOIL that out and come up with a bigger least common multiple. Alright, let's try it again. We've got 3x squared minus 9x minus 30 and 6x plus 30. So I've got 3x squared minus 3x minus 10 and 6 times x plus 5. Which is 3x minus 5x plus 2. This is 2 times 3 times x plus 1. Okay, if we want to build the least common multiple, we are going to start with one of them. It really doesn't matter which one we start with, so I'm going to start with this one. And I go to the other one and I say, what does this one have that I'm missing? Well, clearly I am missing an x minus 5 and an x plus 2. But I am not missing, I've already got a 3. Sorry for yawning. A little tired today. So, here is my least common multiple. Well, I guess I could multiply those together and get 6. Oh, it's the bat phone. So, let's see here. That would be x minus 5, x plus 2. So I guess that would be the more accurate least common multiple. I do want you to be able to multiply 2 and 3 together. I'm pretty sure you're capable of doing that. Let's move on to something more difficult. Example 3 talks about simplifying. Alright, so I've got to factor all of these denominators. So no GCF here. I definitely see a GCF inside of there, but we'll handle that in a minute. So I break this down. I got x plus 4, x plus 1. And over here oops, what happened there? 5x. I forgot. Pull out my GCF of 3, and that leaves me with x plus 1. Okay, now, what is this denominator missing that the other one has? Well, definitely missing a 3. So I'm going to multiply top and bottom by that. Doesn't look like it's missing anything else. It's already got an x plus 1. So I'll come over here. What's this denominator missing that the other one has? Looks like an x plus 4. So now they have the same denominators, and I can add them together, right? Okay, so 3 times 1 is 3, plus, and then I can distribute this, 5x squared plus 20x. Alright, now, we know that as good math students, we are going to write that in decreasing order of exponents just because we are cool people. And of course, we've got that denominator 3x plus 4x plus 1. There's my final answer. No, I'm not going to make you FOIL all the denominators. You can leave them alone. Now, I had to distribute on this one right here so that I could get the numerator together. But no, I'm not going to be tricky and try to make you refactor the top and cancel. That's not my game here. My game is to see if you can get the denominators to be the same and add these two fractions together. So don't worry about redoing the denominators again. And on to another example. Hey, if the denominators are already the same, don't make this any more complicated than it has to be. Right? If the denominators are the same, then just add the numerators together and be done with the question. Don't make it any more difficult. I don't have to get common denominators if I already have common denominators. That doesn't make a whole lot of sense. Okay, let's get some more practice here. So I've got 1 over parenthesis, parenthesis. I don't see a GCF there. Definitely see a GCF there. Oh, we're going to try another one here, and I'm sorry I got interrupted there. But, so I'm factoring this denominator right here, and I see that I have x factors of 12 whose difference is 4. That have to be a minus 6 and a plus 2. Over here I have a GCF, as I said before. I'm going to pull that out and give me x plus 2. Alright, so what am I missing over here that I have on the other one? I'm missing a 4 for 1, so I definitely need to multiply the top and bottom by 4. What am I missing over here? I'm missing an x minus 6. So I'm going to multiply the top and bottom by x minus 6. Okay, we can distribute this and have 3x squared minus 18x plus the 4 that's over here all over 4 times x minus 6 times x plus 2. Like I've said before, please do not worry about foiling the denominator, distributing. Don't waste your time. You don't need to worry about that. I want you to leave your answer in this form and just go to the next question. You're wasting your time if you don't. Okay, so I see a GCF down here, and I also see a GCF there. So I have 7y over y squared minus 25. Oh, look, there's a difference of perfect squares. Yep, so I can factor that one here in a second. So, continuing to factor this, I've got 7y, 5. This is y plus 5y minus 5, right? That difference of perfect squares. And then I've got my 4 and 3y plus 5. So what's this denominator missing that the other one has? Obviously it's missing a 3, so I'm going to multiply the top and bottom by 3. Okay? It doesn't look like it's missing anything else, so I'll come over here to this one. What's this one missing that the other one has? It looks like it's missing a 5. And it's also missing a y minus 5. So you got to multiply the top by 5 and y minus 5. Ooh, that's screen. Okay, so there is a 21y. Be careful. The minus goes with the 4 and the 5, which is minus 20. So minus 20 gets distributed to both of those. That makes minus 20y. And minus 20 times negative 5 makes a positive 100. All over. 3 times 5 is 15. I will multiply those together, but beyond that, I'm not going to multiply any of that rest of this stuff together. So let's see here. I've got some like terms that I can combine together right there. 21y minus 20y makes 1y plus 100 all over 15 times y plus 5 times y minus 5. And that's as simple as that one gets. Okay, next problem to practice with. Okay, so I've got an x. I can take a 3, that makes x squared minus 3x plus 2. And a 3 again, giving me x squared plus x minus 2. Alright, now I gotta keep factoring, because I think I can keep factoring those two. I've got 3, and then factors of 2 whose sum is 3. Okay, that should be pretty easy, right? Minus 2 and minus 1. They multiply together to give me positive 2, but they add up to negative 3. Okay, then I have, over here I've got 3 and x plus 2 and x minus 1. Their product would be negative 2, but their sum would be positive 1. Okay. So, let's see. Before I go further, what is this denominator missing that the other one has? It's missing an x plus 2. So I'm going to multiply top and bottom, and I'm kind of running out of room here. So x plus 2, x plus 2. What is... Alright, so we need to complete this denominator, and it's got a 3. It's got an x plus 2, it's got an x minus 1, but it's missing an x minus 2. So I'm going to multiply top and bottom of this by x minus 2. So we're going to distribute this. I got an x squared plus a 2x. Okay, we're also going to FOIL this. And maybe I need to do a box on that somewhere here just to kind of do this right. 2x plus 1 and x minus 2. 2x squared minus 4x plus x and minus 2. Make sure I'm right there. Yeah. So keep in mind, you got this negative going on here. Let me bring that down here. You got this negative, which applies to everything in here. So maybe I'll leave that, and I'll talk to you about that in a second here. But we have 2x squared minus 3x minus 2. That's from the box. I got that from the box. When you add your middle terms there, you end up with a minus 3x. Okay? But this minus 1 is going to apply to all of those. Now, I am going to write this denominator one time because I really don't feel like writing it 2 times. So we have x squared, oops, sorry, let me put it down here. X squared minus 2x squared, that makes negative x squared. We have 2x minus negative 3x, that becomes plus 3x or 5x. And then this negative also has to be distributed to the negative 2 down there, making a positive 2. Now, if you want me to rewrite that a different way, I guess I could write x squared plus 2x minus 2x squared plus 3x plus 2. So I could write it out, actually, instead of just kind of doing that out loud in my head or, talking through that. But then your denominator for this, 3, x plus 2, x minus 1, x minus 2. No, I'm not going to box all that stuff in the denominator. I'm going to leave it as is. Okay, we've got complex fractions to deal with. Complex fractions. These are examples of complex fractions. Just keep in mind, we can rewrite this in a side-by-side format so that it's easier for you to see how to multiply by the reciprocal. That's what we're going to continue to do, is multiplying by the reciprocal. Now, there's other work that needs to be done. For instance, we would have to do more work in this example before we could just multiply by the reciprocal. So let's take a look at some examples, maybe some simple ones, maybe some increasingly different ones. Okay, this has got a denominator of 1. You know what? You've got a fraction, or a numerator, and a denominator. Ignore them and do them separately. Okay? So these are factor denominators. So what is this denominator missing? It's missing an x. So this is 1 plus 3x over 1x. Alright? Let's worry about the denominators here. What is this denominator missing that this one has? It's missing a y. So multiply top and bottom. 5 plus 4y over 1y. Now, the whole idea of multiplying by the reciprocal, alright, instead of dividing, we're going to multiply by the reciprocal. So I took this fraction right here, flipped it over, and set it next to the numerator, and then treat it just like straight across the top, straight across the bottom. Now, nothing nice is going to happen there. There isn't one bit of canceling that's going to happen there. So don't get all, don't worry about that. None of that is going to have any reducing. So leave it alone. Don't try to hurt yourself. Sometimes these simple ones are better if you actually write them in a side-by-side format so that you can see that you are multiplying by the reciprocal. You're taking y over 1 and flipping it over. So we get 1 over xy. Sorry, I got interrupted. So 1 over xy is my final result. Okay, the next one. Okay, we're looking at here. 3 over this particular. So ignore the 3 for right now, okay? And worry about the denominator here. This is 1 divided by 1. It's missing a 2 and a y, so I'm going to multiply the top and the bottom by 2 and y. So I have 2y minus 1, 2y minus 1, all over the denominator of 2y. 2y minus 1 all over the denominator 2y. Of course, we had a 3 up here. Now, if you want to, you can think of that in a side-by-side format, right? 3 over 1, because anything can be divided by 1, divided by 2y minus 1 over 2y. And then we can flip the second fraction and do our multiplication. Gotta hurry up because the kiddos from next class will be coming soon. 2y minus 1. Please do not try to cancel out these 2y's. Please do not think 6y and 2y cancel out. There's subtraction involved. You stop right here. Any step forward of trying to reduce this will result in bodily injury by, the red pen of death. I do not want you to suffer any consequences or harm because I want you to get good grades. And now I'll do my next example. I was going to do another example, but it ended up being way more complicated than you or anybody else in class needed. So that's the end of the notes.